I hope you are fine. So today we are going to solve the problem of the day for 18th January. This is a hard type of problem. Topics are array, DFS, graph, priority queue, matrix, shortest path. Right? Okay. So the question is minimum cost to make at least one valid part in a grid. Actually, I have solved this problem earlier. Now I want to explain it to you. Okay, so now the question is given a m cross n grid, each cell of the grid has a sign pointing to next cell you should visit if you are currently in this cell. Okay, so so let me explain you quickly. So the grid is like this. If we have one, that we have to move right. If we got two, that we have to move left. If we got three, then we have to move down, and if we got four, that we have to move up. So this is how we are given a grid, right? Now we have to calculate that we can change any grid with cost is equals to 1. Okay, in this particular grid we are we have to start from here, and we have to reach this point with minimum cost. We don't have to worry about the shortest path or the longest path. We just have to worry about reaching here with the minimum cost, right? So we can change this and this so that we can reach here with the cost is equals to 2. So we have to change this and this. So for this path we have to pay the cost of 3, right? So the answer is 3. And we can take any path like this. So we can change this, now we can change this, right? So this is also one path, this is another path. So these are two paths which has the minimum cost, right? In this particular example, it is possible to reach till end point using 0 cost. So answer is 0, right? I hope so. In this particular path, the cost will be 1 because we have to change this to downward, right? I hope you understand this problem. So this is a standard grid type of problem in which we can use DP, right? So how to use DP? Reaching at any or we can use BFS only, which is birth first search, right? So reaching at any grid or any cell, we can check the total cost. If we go right, we can check the total cost. If we go down, we can check the total cost if we go left, and we can check the total cost if we go up, right? So let's say we reach this cell with cost 0, 0, 0 and 1, right? So we reach this cell. Now in how much cost we will reach this cell, and this cell, right? So we will reach here in exactly. So we reach here at one cost. We don't have to pay anything to reach here. So this will also one cost 1. This have 2 and this have 2, right? And following this path, we can be here in just one cost, so that cost will get override, right? So this is how using BFS we can find the minimum cost to reach here, and that's what we have to find, right? So we have created a direction array. We have found the dimensions of the grid. Now we have to create a DP, right? We have initializing the all the costs with infinite, which is the largest integer possible in the Python. So we have assumed that reaching here is will cost us infinite at this point of time, and we will find that any cost which is less than infinite is possible. So we will count that cost and return it to you. Okay, and we will initiate the cost 0, 0, which is reaching here will cost us 0, because it is the starting point. We are creating a queue for checking on the all the sides of the current cell, and we have appended a 0 comma 0 because we are standing here. So while queue is not empty, we have uh, we have like taken the current status of our cell. Now direction is, so the direction is the direction which is the direction of the current cell. -1 means direction is in the 1 2 3 4 format. We have to check the direction in 0 0 indexed. Now we have we are calculating the dy dx dy, because so the coordinates of the next cell. So this is the coordinates of the next cell, adding dy to the x and sorry, dx to the x and dy to the y. Now if so we are checking the necessary conditions, that new index should be in the range of the grid. We are checking if so we are checking if we reach here in lesser cost. So we are checking it here, and if it is possible, then we will append this queue again in the cell to the left, because this is in this route, this will be the this will be of minimum value, right? Minimum value means minimum cost, because assume you are here, right? And you are at the cost of 5. Now if you go here, you are again at the cost of 5, but this is the cost of 6 and 6. So this has the minimum cost, so we don't have to use priority queue for that. We can just append it to the left, right? And then we are just went back to all the directions. Now we are again checking the conditions, and if cost is lesser than the previous cost calculated, which can be infinity or cannot be infinity, can be infinity or may not be infinity, then we are just calculating the cost. So continuing this operations multiple number of times, we will continuing this operation multiple number of times, we will reach this point, right? And then we will return the cost of this point. So I hope you understand my this approach. This is a very standard approach of BFS. This is a direct question from BFS. So you guys can read about BFS from here also, but you can read on Google. I hope you don't have any doubt in this approach. And if you have any questions regarding me or this solution, please ask in the comment section. I hope you understand this problem well. Thank you for your time.